Hello students, welcome to my channel. Let us start the lecture series 1. Here we will discuss about in this lecture regarding the computer architecture, which is related for the BCA first semester student, which is introduced by the Kopla University and as well as Vijayanagara Sri Krishnadeva University, Ballari. And this academic 26-27, they need to study these subjects. Apart from, I have started with the computer architectures. In the computer architectures, I have let us see what exactly we need to study in this computer architecture. Let us see the syllabus. What are the topics we need to cover in this everything. I think you can see in the screen we have a computer architectures, which is a source code called 26 course code we have here, 26 BCA 1-2. Around in this we have a 5 unit we have here. Apart from a digital principle, we have first unit and number system we have here, and third one combination circuit we have here, and the fourth unit we have a computer organizations and design we need to learn, and finally we have a pipeline and as well as a vector processing we need to study. Apart from the syllabus, I will start with the entire syllabus. I will discuss entire syllabus with a different lecture series. Let me start today with the first unit that is called digital principles. Apart from digital principles, I will discuss some basic topics which is we can see in this syllabus that is called digital signals and digital logic and digital computer. Later we'll see further topics. Okay. Without wasting time, let us start with the topic which is called digital principle. Right. So digital principles. Computer architecture. So before going to start with the computer architectures, let me know how many people have you know about what do you mean by computer architectures. So computer architecture is nothing but the set of rules and methods that describes the functionality, organization, and implementation of a computer systems. So this is what exactly we need to say a computer architectures, right? So here is a computer architectures where you can is able to see in terms of the in terms of a video. So you can see here, just wait. So here is the you can see able to in terms of the videos, central unit, CU, control units we have here, and arithmetic logical unit and control unit and register logical unit, resistors. So on we have a lot of the things we need to learn in the computer architectures. Okay. So this is what exactly the how exactly the data has been processed in terms of the computer architectures. So here, let us start with the first subtopic that is called digital principles. Okay. So in the digital principles, let me start with the introduction. What exactly the digital principle is going to say here. Here, in the modern world of the electronics, the term digital is probably most often associated with a computer. It certainly is difficult to think of an area of a life today that is not influenced in one way or another by a digital computers, right? Checking and where we can able to use in terms of the digital computers, we can able to check in. We have in savings account at the bank, automatic automobile insurance we have here, credit card account, federals and state income tax, airlines tickets. The list of functions controlled by the large computer system seems to be almost endless. So these are the entire things where we can able to handle in terms of the digital computers. So if you think that without digital computer, can we handle with these things in terms of the manual? Definitely not, right? So the availability of such a computational power can be traced directly to the development of digital integrated circuit. So whenever we use these kinds of a digital computer, we started with an integrated circuit called IC chip. That is called digital integrated circuit we need to say. So let us see what exactly the IC here. The semiconductor industry provided the first commercial available family of digital IC chips. In the early 1960s, these devices were used to develop smaller, faster, more economical, and more powerful digital computers. So, in digital computers, we supposed to use digital IC chips in the year of 1960. For what sake? To develop a smaller, faster, and more economically and more powerful digital computers. They were also used in great many other applications. Also, they have implemented IC chips. Today, the digital circuits and systems can be found in almost every field of electronics. In communication, the principles of digital electronics are found in satellites. We are using as a telephone switching and transmission network we are supposed to use, and in navigation systems also we are supposed to use IC chips. Right? I think so many people are using games. In the games we are supposed to use navigation systems also we are using here. In the previous in the later year we supposed to use some manual gaming systems for older TVs, right? At that time we supposed to use remote control. That is called a navigation system we supposed to use here. So digital circuit in the area of consumer electronics are found in compact disc. We supposed to use VCR and televisions. The process controls in industrial applications and electronic system used in medicines have benefited greatly from the advance in digital electronics only. The list will not doubt continue to expand over here. Right? It's ongoing for the upgraded notions. Every time we need to go for upgradation. So let us see a digital electronic. An introduction to the field of digital electronics cannot cover all possible applications, but a collection of basic principles can be identified over here, where in this topic. So these digital principles are basic for this text, and they, along with a number of applications, are intended to provide the background for you to succeed in the modern world of digital electronics. So these are the things we need to, principles are to be used to identify in terms of principle, right? So definition for digital signals. So this is all about what we learned is, that is introduction regarding the principle. Now let us see what do you mean by digital signals. As you know that in the terms of the digital signals, signals is nothing but in terms of, you might have seen in hospitals in terms of analog signals and digital signals also, we have analog signals and as well as a digital signal. These are the two signals we can able to see in come across with the daily life. Okay. Let us see here. Digital signals, which are the basic encoding of modern technology and communication, represent data as a discrete binary number, either in terms of zeros and as well as a ones. Digital signals are highly efficient, more applications like telecommunications, computing, and multimedia. These are the platform we are supposed to use digital signals. Zero here, binary numbers are zero. Zero is nothing but no data is present. It is in terms of electricity, digital electricity, in the sense the power has been off. Whenever we have a one, nothing but data has been present and the power supply has been supplied. Sometimes we need to say zero is nothing but is off and one is nothing but as a on. Right? Here is some of the diagram you can see in the screen. The first one is analog and second one is a digital, which is in terms of a discrete, and analog, which is nothing but as a continuous signals. You can see in the temperature and as well as it is continuously flowing from 20 to 80 Celsius. But when we see the in digital, that is in terms of the discrete level, that is nothing but which is in terms of a graph. There is a difference between the from point to point over here. Right? Every time we are getting as a different Celsius. But it is not in a continuous manner, but it is in terms of a discrete manner. For that say we say it is a digital signals. Right? And I will show another diagram. So you can able to easily understand the how exactly we need to say digital and analog. You can see the diagram here. We are showing the continuous flow of data in terms of these signals. This signal shows the analog signals. When we see the digital signals, that is in terms of dot, 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 dot. That is, whenever we have at this point, again, I need to go from here, it again here, and again here. So that is nothing but this is in terms of a discrete manner we need to say. That is the difference between this analog signal and as well as a digital signals, right? And next, so digital logic we need to steer. In the digital logic in the computer architecture is underlying the physical and mathematical framework that process the binary data. So binary data in the sense zeros and as well as a ones. Using the discrete voltage state representing in terms of zeros and as well as a 1. 0 represents the off and 1 represents the on over here. So digital logic is the basic of electronic system such as computers and cell phones. Digital logic is rooted in binary code, a series of zeros and ones, each having appropriate value. This system facilitates the design of electronic circuit that convey information, including the logic gates. Logic gates in the sense and or not NAND nor XOR gate. These are the different gates are available in the digital electronic circuit. We will see these gates in terms of the further classes. Okay. So digital logic gates functions include and or not. The value system translates input signals into specific output. The digital logic facilitates the computing, robotics, and other electronic applications. So here is a computer that is in terms of the digital computer. How exactly we need to process? ये उसको बुला लीजिए उसको. ये चल मत मैं आते चले 5 मिनट चल आ तो. నేను క్లాస్ వెళ్ళాము ఆటో బేస్ వెళ్ళాను. Let us start with the digital computer. The digital computer is a digital system that performs various computational tasks that performs various computational tasks. Digital means data is represented using discrete, distinct values, that is nothing but numbers, letters, or maybe symbols rather than the continuous physical quantities. So you can see that block diagram of a digital computer, which contain the RAM, CPU, input devices, and output devices, and as well as input-output processing. Also, you can see in this diagram. So regarding this diagram shows that how we are going to connect the input devices with the particular system that is called a random access memory, CPU, and whenever we pass the input device like a keyboard, mouse, when we operate this, whenever we pass the setup instruction to the input and output processor, it will take out the pass through the central CPU and then it will throw to the RAM, and then again whatever the output we are getting, that should be passed through the output devices like a printer or maybe a projector or maybe a monitor, right? Regarding this in details, we will study in the further lecture series. Okay, if at all you need, you just commit the regarding this topic, so I can make another video for regarding this diagram. Okay. Next, a computer architecture. A computer architecture is concerned with the structure behavior of the computer as seen by the user, including the information format, the instruction set, and the techniques for addressing memory. The architecture design a computer system is concerned with the specific of various functional models such as processor and memories and structuring them together into a computer system. Generally, in this topic, we need to study one human architecture. For that sake, I am discussing the computer architecture. In the computer architectures, we can discuss with the two types of computer architectures. One is called one Neumann architecture and as well as Harvard architectures. One Neumann architecture describes the framework, structures that a computer's hardware, programming, and data should flow. That is what exactly one Neumann architecture describes. So what exactly the one Neumann architecture include in the sense? It contains some of the following components. The first component is, as seen in the previous diagram, that is computer architecture diagram. It contains the central arithmetics unit, that is central arithmetic unit, which today is called the arithmetic logical unit. That is called ALU, we need to say. This unit performs the computer computational and logical functions. Next, memory we supposed to use. More specifically, the computer's main are fast memory such as random access memory. You all are familiar with the RAM. Okay. A control unit that direct other components of the computer to perform certain action such as directing the fetching of the data or instructions from the memory to be processed by the arithmetic logical unit. And the fourth one, that is man-machine interface, that is called input devices and as well as the output devices. We are passing the instructions, we are getting the output according with the instructions, right? That is called input and output devices, such as keyboard for input and for displaying for the monitor as a output. Here is a when human architecture. Input devices we are passing, as you know that we supposed to use regularly mouse, keyboard, everything we are using for the input devices. That should be passed in terms of the CPU that will perform entire the operations and store into the memory unit and then pass to the output devices. The memory unit will be stored either in terms of the permanent or a temporary. That doesn't matter. But whenever we want to display output devices, that should be stored for the memory unit, right? So that should be stored on the base of this processing. That is control unit, arithmetic logical unit, and register. So entire thing should be performed by the central processing unit, and then that should be stored and then will pass to the output device. Output nothing but projector, monitor, whatever the device used by the customer. So this architecture is called Van Neumann architecture, we need to say. Second step I told in the architecture, that is called a Harvard architecture, we need to say here. Generally, in the previous, what I said here, so in one Neumann architecture describes the framework, structure that computers, hardware and programming and the data should follow. How exactly data is going to flow from top to bottom, bottom to top, and from input to CPU and then output. So, but when we talk about the Harvard architecture, the physical separate storage and signal pathway for their instructions and data. In a computer with Harvard architecture, the CPU can read both and instructions and data from memory at the same time. For example, a computer architecture based on the one Neumann architecture is the desktop personal computer. Of course, one Neumann architecture is nothing but a personal PC. That is called a desktop publication computer, personal computer, we need to say here. But when we talk about the Harvard architectures, microcontroller based computer system, that is called DSP, digital system processor based on the computer systems, are the example of Harvard architectures. So microcontroller based computer system, that is called a digital system processor, whenever we use that kind of architectures or Harvard architecture, we need, where we are going to read both instructions and as well as the data from the memory at the same time. That is called Harvard architecture, we need to say here. So this is all about your basic computer architecture regarding this. So today here we are discuss about what do you mean by digital computer architectures and digital principles. In the digital principles, what is the digital logic and what is digital computers, And what are the one human architectures also we discussed. Again, another type that is called Harvard architectures also we have discussed here. So these are the basic things I have discussed here, not entirely I have discussed here. So for in further lecture series, I will discuss in depth so you can able to easily understand. So before we are going to learn with the computer architecture, first you need to know the basic things. What are the input devices we are using, and how to start the computer, how to shut down the computers, and what are the things, what are the components are there in CPU, like RAM, motherboard, SMPS, right? SSD, hard disk. So these are the some of the components like peripheral device we have here, motherboard we have here, right? So these are the some of the components should be learned before when we are going to learn for the computer architectures. And output device like a monitor, projectors, printers, lot of the things we have here that is called input, for which we need to say it is input, and which we need to say output, and what are the components that should be used in the computer. These basic things should be you need to learn before we are learning on the computer architecture. Without knowing these things, we are very difficult to understand the computer architectures, right? Definitely, we will see in the next lecture series with the a new topic, right? So I hope you understand this concept in detail with the basic knowledge. So definitely, you will comment regarding this video, right? If you are interested with the next video, definitely you commit your opinion regarding this video in the comment box. If you like this video, kindly share to the your friends. Okay, then we'll see in the next lecture series. Thank you.